manually remove any large pieces of plant and animal debris and stones from each sample. Now take 5 identical graduated cylinder containers with a flat base for this. Now introduce approximately equal amounts of the 5 soil samples into the 5 cylinders or jars, such that almost half of the jars are filled with the samples. Label the jars appropriately. Then add equal quantities of water to each of the containers such that the water level is at least 5 to 10 centimeters above the soil samples in each jar. You can also add a teaspoonful of detergent powder into each of the jars. The detergent acts as a surfactant and helps in the effective separation and resolution of the sand, silt, and clay components. Now cover each container using a lid or the palm of your hands and shake the contents vigorously for a couple of minutes in order to homogenize the soil by breaking down larger soil particles and also to achieve a thorough mixing with the water. Do this for all the 5 sample containers. Leave the containers undisturbed for a couple of hours to overnight to allow the components of the soil to settle down by the force of gravity. For accurate results, it is recommended that the soil particles be allowed to settle down for at least 24 hours. At the end of a few hours to overnight, observe the soil samples in each of the containers. Determine the sand, silt, and clay layers which by now would have separated into different strata within the containers in descending order of size. The bottom of the container has the large. Now starting with the first sample container, measure the depth of the sand, silt, and clay layers of the soil using a measuring scale. In case you're using graduated cylinders, you can directly use the milliliter graduations printed on the shown here and calculate. This experiment has 47.4 angle. So sample